All right, welcome back. In this particular video, we're actually going to see how we are actually going to implement this hierarchical clustering and every concept that we've been discussing so far, right? We are going to see in implementation of that over here. All right, so we're going to use a certain data set, which is customer spend data set, right? We're going to use that. When we load the data, you actually get to know what is inside this data. All right, so let's proceed and then start by loading the various libraries that we're going to use. Right, so all these are libraries that I'm sure you are familiar with, since we've been using them over and over again. So we don't have any new library in here. We don't have any new library in here. They are just the old libraries that you know, right? The likes of pandas, numpy, matplotlib, and then this inline. I'm sure you know what that means, right? To help us plot our graphs inside the Jupyter notebook, right? And then the z-score to scale our data, and then also Seaborn. All right, so I'm sure you are familiar with all these libraries, and we don't need to spend much time over here. All right, so now after we have loaded our data, after we've imported the various libraries, the next thing that we're going to do is to load our data. All right, so this is what we are actually going to do over here. We're going to load our data, which is stored in a CSV format, right? Which is stored in a CSV format. So we're going to use this read underscore CSV to read our CSV file, right? So this function is present in pandas, and after we store everything in a variable called df. Okay, so now if we see the first 10 records, so the first 10 rows that we have in our data, right? So this is basically what we have, right? This is what we have. So let me actually do it this way so that you can see everything. Yeah. So I think it's better now. So what we have over here is this the customer ID. So this is actually representing some customers that visit a shop, right? Some customers that visit a shop. So when when customers visit the shop, they take records of the customers, right? So as you can see here, they are given ID, right? So each customer that comes to the shop, they give the customer ID, right? And then the name of the customer. So in this case, we're just giving a hypothetical name here, right? Customer A, customer B, customer C, right? So there's just a hypothetical names over here, right? And then monthly, on average, how much they spend, right, on the items at the shop is also being recorded over here. So that is average monthly spent is also being recorded here. And the number of times they visited the shop is also being recorded, right? So as you can see, customer A visits the shop 2 times per month, right? So it's also being recorded. And then the items that they buy, so at the shop we have apparel items, we have fruit and vegetables, we have staple items, right? So these are the items that are available in the shop, and that is what the customers come and then spend their money on. That's what they come and then buy. All right, so having an idea about the data that we have, right? So let's see some of the things that we can actually infer from here, right? Let's see some of the things that we can actually infer from here. Now, if we see, let's take the first customer. So this is customer A, right? Customer A. So on average, right? On average, this customer spends like $10,000, right? On these items, right? Apparel items and fruits and vegetables and staple items, right? So you can see that if you see the number of times that this customer visited the shop, right? Just 2 times, right? But they spend a huge amount of money, right? They spend a huge amount of money, on these items, right? And you can see the items that they buy, right? So apparel items, right? Just one of them, and then fruit and vegetables, one of them. They don't actually like staple items, right? So you can see these are the things that customer A actually likes, right? So if you take customer B, you can see that on average they spend 7,000. So this values that you can see here could be less, it could be more, right? But we are talking about average here, so it could be very less, it could be very high, right? So this is just an average, okay. So the number of times, they come to the shop 3 times, right? And you can see that for them, they don't like apparel items, right? What they like most is fruit and vegetables, right? And they also like staple items most, right? Unlike customer A, right? So it's just complete opposite to that. All right, and you can see customer C also 7,000, and the number of visits is 7, right? So mostly they visit the shop the most, right? And they like Apple items. I mean, they buy some Apple items and fruit and vegetables, but mostly they buy staple items, right? They buy staple items the most. If you see customer E, right? Customer E is actually that is this customer, right? Customer E actually visited the shop. I mean, I think it's the second most frequent customer at the shop, right? They don't like Apple items, right? They don't like Apple items at all. They like fruit and vegetables the most. So just like customer B, right? So this one's customers like fruit and vegetables a lot, right? And if you can see over here, they also like staple items, right? They also like staple items, right? And if you see this customer F, right? Customer F also spend on average 4,000, right? And you can see that they don't actually come that much. I mean, 3 times per month. They don't like Apple items at all. They don't like Apple items at all. They buy very small amount of fruit and vegetables, but they buy staple items the most, right? So if you see this customer too, this customer also behaves similar to this customer, right? Behaves similar to this customer, right? That is customer G and then F, right? Customer G and F, and then customer B, right? They all spend most of their money on fruit and vegetables, right? And staple items, right? And then you can see these customers that they also like very few amount of fruit and vegetables, but they don't like staple items at all, right? And there are some customers who also don't like apparel items at all, right? They don't like apparel items at all. All right, so these are some of the things that you can actually infer from here. So we can actually cluster these customers into groups and then see which customers behave similar to each other, right? So that's what we are going to do over here to actually figure out which customers behave similar to each other. All right, that's what we are going to see in this particular video. So remember, as we talked about in the k-means clustering, we don't have some targets over here, maybe some targets over here that we will try to build algorithm to predict, right? We don't have something like that, right? We don't have something like that where we will build algorithm to, we will use these features and then we use it to predict. No, it's not like that. Here we want to group customers according to their behavior and how they are behaving, when they come to our shop, right, how they behave. So we want to cluster them into groups, right? We want to cluster them into groups. So that's what we are going to do. And that's why we call it unsupervised machine learning. We don't have anything to supervise over, right? We don't have any target over here to supervise over, right? So we have, in this case, we just want to group them. Okay, we just want to group them. So that's basically what we have over here, and that's why we call it unsupervised machine learning. Okay, so now having gotten an idea about this, let's proceed right here and then select some of the items that are necessary for us for our discussion, right? So we don't actually need these customer IDs, right? We don't, and then the customer names, we don't actually need it. Moving on. Okay, we don't actually need these. So what we are going to use is these ones, right? These are the ones that we are actually going to use to do, to build our algorithm and then do the clustering over here, right? That's what you're going to use. We're going to use these parts. We don't need the ID, we don't need the names over here, right? So over here, if you can see, we are selecting all the rows, right? So we're selecting all the rows, right? We are selecting all the rows over here. We're selecting all the rows. And then we are selecting it from, if we consider the column, we are selecting from column the index 2 all the way to the last one, right? So if you remember how this is pinning there, so this is going to be 0, 1, 2, 3, 4, 5, and then 6, okay? So if we are starting from 2 and then we are moving on to all the way to the last one, which is the index 6, right? So we are cutting off this, right? That's why we are starting from 2 over here, right? And then selecting everything afterwards. All right, so that is done, and then after that we store everything in a variable called df_attribute, right? So we see that this df_attribute contains the attributes that we're going to work with. All right, so let's move on and then see the first 5 rows of this, right? So now you can see that we don't have this the customer ID and the name, right? We don't have that. We have it starting from average monthly spend all the way to staple items, right? That's what we have over here. Okay, so that is done. That is done. Now, what we can do is to scale our data, and I'm sure by now you know why we are going to scale our data, right? I'm sure by now you know that because we've been using this in our previous classes, right? So if you see the data points that we have, right? If you see the data points that we have, if we consider the average spend, we have a huge values here, 10,000. Now, if you see the apparel items, right, you can see that some are even zeros, right? One here, 10 here, 3 here, 1 here. They are very, very small values, right? So they are not on the same scale, right? They are not on the same scale. So what we can do is to actually scale it so that they all be on the same scale, right? We have to bring them all to the same scale. Otherwise, if we use the distance measures over here, one scale is going to outweigh the other, right? One scale is going to outweigh the other. And the importance that these columns are going to give us is going to be ignored, right? So only this one is going to be taken more seriously, right? More importance is going to be placed on this, depending on the distance that. So if we take say 10,000 minus 7,000, right? And then we find that this is the distance, right? And then we square it. This is actually going to give us a very high value. Remember, this is the Euclidean distance. I'm sure you're familiar with this, right? So I'm just giving you a highlight of that, right? So you can see that this is going to give us a high value as compared to if you find this, right? If you consider the distance between 1 and then 0, even if you square it, it's still small, right? And this is actually going to give us a very less impact, right, as compared to this. So this is going to outweigh this. So we need to scale everything and bring it to a common scale, right? So that's why we are applying the z-score over here, right? So we are applying the z-score on this df underscore attribute. Then we store it in our df underscore attribute scaled. So now remember that what we are working with is df underscore attribute, and now we've scaled it. So if we are calling it df underscore scaled over here, right? And then we are going to see the first 10 of it. So let's do that and then see what do we have over here, right? Now you can see that we've been able to scale all of them, right? We've been able to scale all of them without any of the values being very high values and others being small. So even if you see the average monthly spend column, you can see that it has brought it down to a very low value. So if we consider it with the others, they are all on the same scale now. All right, so having gotten that, now we can use what is called a pair plot, right? You can use the pair plot over here. And then we pass in our df attribute scale, right? We can use that one. And then let me actually show you the output, right? So that we can work alongside. Okay, so this is the output that we have. So over here, you can see that this seaborn, inside the seaborn, we have this function called pair plot, which will help you to plot all the attributes that you have. The distribution of all the attributes that you have in your data set, right? And we are setting the diagonal kind to be KD, which is the kernel density estimate, right? That gives us the smooth, right? The smooth diagonals, the smooth graph that you can see at the diagonals, right? So basically that is it. And if you see the correlation, you can see that there's no particular correlation between any of the attributes here, right? So we are good to go. We will not run into any problem, right? So basically, if the attributes are correlated, then you might end up running into something we call you might run up into something we call multicollinearity, right? You might end up in something we call multicollinearity, right? We don't want to run into that. So if you have your data set which having no correlation like this, then it's okay. You can actually work with it, because if they are correlated, let's say if you take average monthly spend, it's very correlated to say number of visits. It means that the information that average monthly spend is going to give you, the same information number of visits is going to give you. So there's no need keeping these two attributes in building your algorithm, right? You can drop one of them, and don't forget, the information is not going to be 100% the same, right? It's not going to be 100% the same. So if you drop one column, you end up losing that information, right? That's when techniques like PCA will come into place, right? Techniques like PCA, that's a principal component analysis. So instead of dropping one column, we can extract information from both of these columns and then form another column, right? Form another feature in here, right? So or a principal component over here, right? We will talk about this later on. We'll talk about this later on, right? So let's not divert from this, right? So our data is good. We don't have that correlation over here, so it's good. Let's proceed and then keep focus on what we are doing. So remember that I told you that with hierarchical clustering, right? With hierarchical clustering, we have two types, right? I mentioned that when we're dealing with the concept behind hierarchical clustering on the whiteboard, right? We talked about the fact that we have what is called the agglomerative, right? We have the agglomerative, right? We have the agglomerative, then we have the divisive, right? We have the divisive. So you can use either of them. So in this case, we are going to use the agglomerative clustering, right? So from agglomerative, right? If we talk about this, it means that we are starting from the individual clusters all the way to having a big cluster. Right, having one big cluster. So that's what you're going to use, right? That's what you're going to use. Unlike divisive, where you start from one big cluster, right? From one big cluster, and then you divide it all the way to you get individual clusters. Okay, so in this case, we're going to use the agglomerative, right? That's why over here you can see that from scikit-learn dot cluster, I'm importing this agglomerative clustering. Okay, that's what we are going to use over here. So now let's proceed over here and then see what we are doing here. So as I talked about in the other videos, if you import your algorithm, right, what you do is to initialize it, right? If you import your algorithm, what you do is to initialize it, and that's exactly what we are doing over here. That's exactly what we are doing over here. So you can see some of the things being familiar with you over here. So this is just if you see this agglomerative is what you can see over here, right? We have the n clusters. I'm sure by now you know why we are choosing 3 over here and how you should choose these 3, right? If you remember when we talked about the k-means clustering, we talked about how you can choose this k, right? So I'm sure if you watch that video, you're familiar with how we choose this number of clusters, right? And then this affinity is nothing but the distance that you want, the kind of distance measures. So over here you can see that I'm using Euclidean distance. So you can use any of the distances, whether Minkowski or whether cosine similarity, or you can use either of them, right? But normally Euclidean distance works. So our advice, you use that, right? So you can use that. You can try any of these Minkowski and the cosine. You can try, or Manhattan, right? You can try any of that to see how well it's going to help you to perform well. Okay, now I'm using what is called linkage over here. I'm using what is called linkage, and the linkage I'm using average linkage, right? So let me show you what that means. Remember that we discussed about this, right? So if we go here, right, we discussed about this linkage, and we talked about this average linkage over here. We talked about average linkage, right? So basically that's what I'm going to use. So I'm going to connect each of the points, right, in my data set, right, from one cluster to the other, and then measure the distance. So that's what I'm going to use, right? To measure the distance from one cluster to the other, I'm using the average over here, right? I'm using the average over here. So let's go back and then see what we were doing, right? So having gotten an idea about what we are doing here, which is the number of clusters, the distance measure that we're using, and then the kind of linkage that we are using. So we initialize everything, then we store everything in a variable called model, right? In a variable called model. So that is done, and let's proceed from here. So normally you initialize it, and then after that you fit it, right? That is, you make it learn. So this becomes our model, right? So over here, this is where the learning starts, right? So our model is now let me do it this way, right? Now our model is now learning from our data, right? Don't forget, this is our data stored in df underscore scaled, right? After we scaled our data, we store it in a variable called df underscore attribute underscore scaled, right? So we're using this fit function to actually fit or learn from this, right? To learn from that, okay? So that is done, and after that, this model becomes powerful because it has learned from this, and we can use it for new data that will come in, right? We can use it for new data that will come in. So you can see over here some of the things that we included, right? That's the Euclidean distance, the average, right? that we use. That's the linkage, and some of the things that we did not. You see the end clusters is there, right? Some of the things that we did not specify. So all these are hyperparameters that you can change, that you can tune by yourself, right? That you can change. So if your algorithm is not giving you the performance that you want, you can come back and then be changing these hyperparameters over here. All right. So all these are some of the things that you can do. Now, after that is done, right, after we fit our model on our data, right, after that is done, what we can actually get is that, remember that we say that, let me actually get rid of this and show you up here, right, actually here, okay, remember that we say that our number of clusters equals 3, right, which means that we are going to have 3 clusters, that is 0, 1, and then 2, right, that is 3 clusters that we're going to have. So if we want to get these clusters or these labels, right, what we can use is our model.labels underscore. If we do model.label underscore, we will see all these clusters, right, all these clusters that have been generated after our model has learned from this. Okay, so if we do that, right, what I'm going to do over here, right, let me actually show you the output so that you can actually understand it, right? So what I'm doing over here is that when I do model.labels, right, if I do model.labels, I'm creating another column. I'm creating another column in my original data set. Don't forget that I'm not using df underscore attribute underscore scale. I'm using df underscore attribute, which is my original data set, right? Don't forget, if you go all the way up, right, all the way up here, when we selected the ones that we want to work with, see that we have df underscore attribute. So I'm going to add another column here, which is my labels, right? Which is my labels. So that's what is happening over here, right? That's what is happening over here. So I'm creating another column called labels, right? And then I'm adding it to my original data, that is df underscore attribute, right? So if I do model.labels, I get to that. Then I create this column over here. So that's why you see labels, and then the various labels that is ranging from 0, 1, and then 2, right, will be appended over here for me, right? That was going to be the content of this label column here, right? So this is just to see the first thing. All right, we've been able to cluster these data into different clusters, right? That's cluster 0, cluster 1, and then cluster 2. Okay, so now let's see which customers are in cluster 1, which customers are in cluster 2, which customers are in cluster 3, right? Let's see, in cluster 0, cluster 1, and then cluster 2. Okay, so let's see that one and then see how well we are doing over here. So over here we are seeing, if we consider this table, right, if we consider our table over here, what we are going to do is that if we pick the labels, right, we want to pick the labels, and then the ones that are equivalent to 0, right, that is those that are in cluster 0, right? So if we run that, now you can see that we have only this, right? We have these ones, right? We have our labels here, and then we have only zeros here. That is cluster 0, right? Those that are in cluster 0. Okay. Now you can see the customers that are in cluster 0. You can see their behavior, right? They have common behavior. You see the amount they spend is quite high, right? The amount they spend is quite high. And then if you see the items that they buy, right? All of them buy Apple items, right? Just one Apple items, right? They don't buy much of fruit and vegetables, right? They don't buy much of fruit and vegetables, right? And if you see the staple items, you can see how consistent it is, right? With the exception of maybe this one that doesn't actually like, but with the other attributes are the same, right? With the other attributes are the same, we can relate them or group them into one cluster. All right, so now you can see how they've been able to group together. Even if you see the number of times they visit the shop, right? It's ranging from 2 to say 5, right? And the items they buy are quite similar to each other, right? So we've been able to cluster them into one cluster, say cluster 0, right? So if we want to market to these people, we know how to market to them, because these customers don't actually buy most of the Apple items. So if they come to our shop, we will not bother ourselves talking about Apple items to them, right? Mostly we will talk about maybe staple items, right? Because that's what they like the most, right? And then probably fruit and vegetables, right? That's mostly what they like, right? And then if we see those that are in cluster 1, right? Those that are in cluster 1 over here too. Now you can see those that are in cluster 1, right? if you see those that are in cluster 1, you can see that they don't like this. They don't like apparel items. None of them even buy apparel items, right? Mostly they buy fruit and vegetables, right? Mostly they buy fruit and vegetables and also staple items, right? That's why we've been able to group them in one cluster, right? So you can see that they have common behavior, and we've been able to group them. So if these are customers that come to your website, or they come to your shop, right, you know how to advertise to them, you know the things to show them, right? So if they come to my shop, mostly I'll talk about fruit and vegetables, right? I'll begin to say, oh, we have a discount on these fruits, right? So I mean, those are the things they're interested in, so I can easily get them to buy those stuff, right? Rather than me talking about apparel items which they don't even like it. They don't buy them. I mean, for the whole month they did not buy a single item of apparel item, so I will not worry them with that. All right, I will not worry them with that, and you can see the amount they spend is quite okay. All right, so I know which items to recommend to these customers. Let's see those that are in cluster 2. All right, now if you see those that are in cluster 2, I mean, a bit similar to those that are in cluster 1, right? They don't buy apparel items, none of them, right? But if you see those in cluster 1, right, mostly they buy fruit and vegetables, but those in cluster 2, they don't actually buy fruit and vegetable that much. They don't buy it that much, but I mean, though they buy staple items, right? I mean, that is what they like, but they don't actually. A very few of them, right? They buy very few of fruit and vegetables, right? Very few fruit and vegetables. Unlike this one, that they buy mostly fruit and vegetables a lot, and they also buy staple items a lot. Okay, but if you see this one, although they buy staple items a lot, but they don't buy fruits and vegetables. So you can see the behavior that they have, right? So we've been able to cluster them into different groups. Now you can see how our model is doing, right? It's actually helping us to group our customers into groups. Now this one is actually going to help the shop owner to be able to know, I mean, if a customer comes, you know what customer is it, what items I should talk to the customer about, right? And how I should approach the customer to increase my profit. I know how to sell, and then which items I should sell them together, right? So I know how to do that. Now if a customer in cluster 1 comes, right, and the customer buys fruit and vegetables, I know how to convince this customer to also buy staple items, because I know they also like staple items, right? And if a customer here comes, right, I know that I should talk mostly about staple items, and maybe give them some discounts and encourage them to also buy some fruits and vegetables which they are likely to buy, right? But I will not bother them with apparel items, right? I will not bother them with apparel items. All right, now you can see how consistent our model is helping us to group customers together. All right, now let's proceed and then see how we can also do this on average, right? So on average, if we do group by, and I'm sure you are familiar with this group by, right? I'm sure you're from, if you're coming from the previous classes. I mean, we've talked about this in the business of NumPy and Pandas. We talked about this a lot, so I'm sure you're familiar with it. So in our data, right, we are grouping our data according to the labels, right? We're grouping our data according to the labels, and that's why down here, right, you can see that we have labels here. So we're grouping them according to the labels, which is cluster 0, cluster 1, and then cluster 2. So right. So on average, customers in cluster 0 spend around 7,833, right? So I know that most of my profits come from customers in cluster 0, right? Most of my profit comes from customers in cluster 0, right? So they are customers that should be very, very important to me, because that's where most of my profit comes from. And those in cluster, followed by those in cluster 1, right? You can see that also 5,166, and followed by those in cluster 2. Okay, and you can see the number of visits that they. So on average, they come to the shop at maybe 4 times, right? And the items that they buy, so you can see that mostly they buy staple items. So staple items is actually giving me a high profit here if you compare it with the other items, right? If you compare it with the other items over here. All right, so mostly you can actually also use this group by, and then see how a summary of this information that you are gaining from your customers. All right. So I hope this is quite interesting insight that you're getting over here. Now, what we are going to do next is to build our dendrogram, right? To build our dendrogram. So what I'm going to use to build this is this. So from scipy.cluster.hierarchy, right? Remember we're using, this is a hierarchical clustering. So you're going to build a hierarchy, right? We're importing this cophonetic. Remember we talk about cophonets, right? So we talk about this cophonetic where we can actually measure how well our dendrogram is doing with respect to the original data, right? That is measuring the correlation between the dendrogram distance and then the Euclidean distance, or whatever distance measured that you can use. Okay, so we're importing this cophonet and then dendrogram and linkage, right? So that, for linkage, if you remember linkage is nothing but these, how we measure it from one cluster to the other, right? So that's basically, that is it. And then the dendrogram is nothing but the dendrogram, this hierarchy that you've been seeing, right? This hierarchy, right? And I'm sure you're familiar with that. All right, I'm sure you're familiar with this. Okay, so that's basically what we are going to do over here. So let's proceed and see how we are going to do it. We're going to use what is called a p-dist over here, right? And this p-dist is going to help us calculate the distance, right? That's the pairwise distribution between the data points, right? So in our data, right, we can actually measure the distance, the pairwise distance, maybe from say 4,000 to 2,500, from 4,000 to say 2,000, from 4,000 to say 1,000, from 3 to 4, from 3 to 3, from 3 to 2, from 3 to 4, right? So this is actually helping us. The p-dist will help us to calculate this pairwise distance. Okay, so that we will be able to compare that pairwise distance with the dendrogram distance, right? So that we see the correlation of the cophonetic correlation, and see how well our model is doing. Now that is done. After that is done, this is what we're going to do over here, right? Let me do this. So now you see that I'm using linkage here, right? I showed you linkage, right? I've shown you linkage here. So the kind of linkage that we are going to use is the average, right? You're going to use the average linkage, right? So we're using this average linkage over here, right? We're going to use that. Now, right, we are using Euclidean here. So the metric here is Euclidean, right? Which is going to help us to measure the distance. You can use any distance measure that you want, right? So we are passing in our data here. We're using our method to be average, and then our metric to be Euclidean. All right. So after we measure this linkage, or we use the linkage, we store everything in a variable called z. Right. We do that. So after that is done, what we're going to do is to measure the cophonetic correlation. Right. Measure the cophonetic correlation. So what is happening here is that if we use this cophonet, right, we pass in this, right, which is going to be the distance, right, which is going to actually be this dendrogram distance, and then the pairwise distance, right? Remember that we're using the p-dist here, the pairwise distance of the data points in our data, right? So we're going to see the correlation between this and then that, right, and then that, and then see how well it's doing, right? So the correlation is going to be stored in a variable called c, right, and then the distribution is going to be stored in this this variable. So all these are just variable names that I'm giving, right? I want to store the correlation in this, and that's what I'm interested in. I'm interested in the correlation. All right, so let's see the correlation that we have. All right, let's see the cophonetic correlation that we have in here. Now you can see that we have 0.86, which is quite good, right? Which is quite good. It means that the correlation between these two, that is the dendrogram distance and the Euclidean distance, right, of the pairwise distance in our data set is quite related, right? So if you remember the distance between A and B, right, we did something like that, and then C and then D, right, we did something like this, right? And then here we got 2, here we got 2.2, and then here we got something like the original was something like 5, right? And then we got here like 4.9, and then we were able to say that these were, the data point here were correlated, right? the Euclidean distance here and the dendrogram distance here were highly correlated, right? So the same thing you can think of this Euclidean distance, right? You can think of that one as this one, right? You can think of that. You can think of the dendrogram distance as this one. Remember that we are all using Euclidean distance to measure all these distance measures, right? You can see the correlation here is to be 0.86 or 87 if you want to run it to 2 decimal places, right? It's quite good, right? So our dendrogram is good, right? So let's see the dendrogram itself, right? Our dendrogram is good. Let's see our dendrogram itself. So we're going to use this to actually plot the dendrogram. So let me do it this way so that you can actually see. Okay, so for plotting the dendrogram, right, what we're doing is to set the figure size, right, which is plt.figure. So we're using matplotlib here, right, and then the fixed size is going to be 10 for the length and then 5 for the height. So 10 here, right? 10. Oh, sorry. So we have let me actually use this, right? Let me use this. So we have 10 here, right? We have 10 here, and then we have 5 here. All right, we have 10 here, we have 5 here. So basically, that is what is happening. All right. So we have, let me write it here. We have 10, and then we have 5. So basically, that is what is happening over here. That is happening over here. Then I'm using plt.title to plot this title, right? So that is the same title that you can see here. Agglomerative hierarchical clustering dendrogram. That is what you can see here. And then the X label, right? I'm using plt.S label to plot the S label, right? That's why you can see sample index, right? So that's the same thing. And then the Y label to be distance, and that's what you can see over here. And then now I'm using the dendrogram function here. See that I have dendrogram function. Remember that I imported dendrogram earlier on, right? And then I'm passing in this this dendrogram distance. Remember that this is the dendrogram distance, right? If I go a little bit up, right? Let me do this, right? So remember that we did the dendrogram distance here and we stored everything in a variable called z, right? So that's what we are passing in. That's what we are passing in over here, right? Let me actually get rid of that. So that's what we are actually passing in over here. And then we have the leaf, the leaf rotation. So the leaf rotation is nothing but this kind of rotations that you can see here, and then the size of it is 10, right? So you can just play around these all these are just some hyperparameters. So I said leaf rotation equals 30. So you can just keep your eye on this orientation of the numbers that you can find here, right? So I'm going to change that one. You can just play around this, and then you can see how. So instead of 30, maybe I should do it 90, right? Or maybe I should do it 45. Let me do it 45 and then run it for you to see. Now you can see how it is. Maybe 90 will actually show a big difference. Let me do that. Now you can see how flat it is, right? So maybe let me do 180, right? So all these are just hyperparameters that you can actually change. Now you can see that it has even 10 completely, right? 10 upside down, right? So this one is not actually what we want. So maybe let me take it back to say 30. Right, it's working better. Now you can actually see the dendrogram that we have here. We have several clusters here, right? We can see this one. You see this one. It's one cluster here. You can see another cluster here. You can see another cluster here, right? And then finally you can see that we've been able to put these ones into one cluster, right? Into one cluster, and then we combine everything, right? Over here, we combine everything together. All right. That's why we are using this agglomerative. Don't forget that we are using agglomerative, right? Agglomerative. That is from individual. That is from individual to one big cluster, right? To one big cluster. So from individual clusters, right? From individual clusters, we combine them together like that. And then finally we form one big cluster. Okay, that's basically what it is. Now we've done everything that we've learned in the concept. I mean, when we got to the whiteboard, right? Whatever we've learned over here, right? We've implemented everything, right? We've implemented everything here. Now what you can do is to actually maybe change the method, right? Remember that here we are using average, right? We are using average. So maybe we can change to say single or complete or centroid. You can change it. So I over here, right, the method here we are using average. You can change this method, right, to say complete. You see that I'm using complete. So instead of average, right, I'm going to use complete, right? So if you do that, right, and then you check the correlation again, you see that we have 0.86 as against 0.868. So this is, this is quite better. This is quite better when we used the average, right? It's quite better because this is although it's all 0.86, but if you see the next one is 0.860, right? But this one is this is 0.868, right? As against this one, which is 0.860. Okay. So when I change it from average, right? When I change the method from average, that is how to measure the distance between clusters, right? When I change it from average, right? When I change it from average to complete, right? This is what I'm getting. So maybe I'll prefer average instead of using complete. I'll prefer average, right? So let me see some of the others that we can also use. This is the dendrogram for it. The dendrogram looks same. The dendrogram looks the same thing over here, right? It looks the same thing, right? It looks same. Now let's say we change it to say word. So there's another one called word. I think we did not discuss that one here, but there's another one called word that you can actually use, right? So if I do that, right, let's see the cophonetic correlation. You see that it has reduced 0.84, right? Now it has reduced to 0.84, right? As against even this one that was 0.86, right? And then when we use the average, we're getting 0.868. So far average is doing better, right? So all these are just some hyperparameter tuning that you can do, right? So changing the hyperparameter. So over here I'm just changing the method. You can also change the distance measure, so maybe from Euclidean to say Manhattan, or you can change it to say Minkowski. So you can just play around and then see which one is doing better for you, right? So if you see the dendrogram for that too, it's the same thing, just that the correlation has reduced. So far I think the average method is the one that we will go with, right? So this is the one that we'll go with. This is the one we'll go with, right? So basically, this is what hierarchical clustering is all about, right? And I'm sure you had a good experience with this, right? So all right, so we'll end it here. We will end today's class here, and then meet in the next class for another awesome tutorial. All right, so see you in the next class.